Okay, so let's see some examples for how this works. So, I think this will be example 1. A says x squared minus 9. We're going to factor this, if it's possible. We're going to factor x squared minus 9. And again, this is a little bit different than what you've been doing in the past because you've just been factoring trinomials. But this is a binomial. Okay. However, this is a difference of squares factoring problem. Can you see why? Keeping in mind that definition we just wrote down. Do I have two numbers that are things that I could square root that are being subtracted? Well, let's look. 9 should be a dead giveaway. That's definitely a perfect square. We could square root that. What about x squared? What would the square root of x squared be? So some of you say 1, some of you say x.
They're the same thing.
No, 1 and x aren't the same thing. Maybe just think about that for a moment. What if I tried to square root x squared? The answer would be something that, if I multiplied it by itself, I would end up back at x squared.
Whoa.
Okay, just like, if that didn't make sense, square root of 9 is 3, because 3 times 3 is 9.
Whoa, so it'd be like...
So the answer is something that I can something that I can multiply by itself to get back here. So what can I multiply by itself to get back here?
X.
X. X times x is x squared. Okay, so the square root of x squared would be x. You with me? Okay. So based on that, check this trick out.
Whoa.
Boom! Yeah! I like doing that. Here's how you factor difference of squares. It's actually very, very quick and very simple. What you do is you set up your two set of brackets, just like you do when you do normal factoring. Okay? And the first thing that you write in those brackets is the square root of the first term. Okay? So the first term here is x squared. What is its square root?
X.
We just found that it's x. Okay, so that goes in both of those brackets. It's the first term in both of those brackets. And the second number you write is the square root of the second term. What's the square root of 9?
3.
3.
But wait, it's negative 9.
In that case, it doesn't matter. Or in this case, it doesn't matter. You ignore the fact that it's negative. Just square root that specific number. Okay? And then to finish it off, you put plus and minus, and you're done.
Whoa.
It's really simple.
It always has to be plus and minus.
It always, well, it could be minus and plus. It doesn't matter. But one has to be positive, one has to be negative. Yeah.
So even if they're both positive, then one has to be positive and one has to be negative?
You mean if this was positive?
Yeah.
You can't do difference of squares then. Difference of squares implies that you're subtracting them.
Oh, I see. Okay.
Okay. So just to prove to you that this actually worked, I'm going to foil it quick and use yellow. Come on, yellow. There we go. Okay, just to show you what I'm doing. So I'm going to foil really quickly here. That gives me x squared minus 3x plus 3x minus 9. Which doesn't quite look like what we started with, but you'll notice that the 3x's cancel each other.
Oh.
And we end up back where we started. Good? Okay, let's do another. B, 16c squared minus 25a squared. So, what kind of factoring is this? Potentially. It's potentially difference of squares. A really good hint is that you only have 2 terms instead of 3. That should be a hint that you're potentially doing difference of squares. Are we subtracting the 2 terms? We are. So we do have the difference part. Do I have 2 perfect squares?
Yeah.
Okay, let's think about this. Could I square root 16c squared?
Yeah.
What could you multiply by itself to get 16c squared? 4c, right? And 25a squared? 5a. Good. Okay. So just like we did last time, set up your 2 sets of brackets. What's the first term in each of those sets of brackets?
4C.
4c, good. You square root the first term. 4c and 4c. And the second term is,
Plus 5a.
tell me the second term.
5A.
5a, you square root the second guy, right? And that becomes the second term. 5a, and then what goes in the middle?
Plus minus.
Plus, minus, or minus, plus. You could do that.
It doesn't matter what order they're in.
The order does not matter.
Cool.